Hey, everybody. Now I'm going to write Leetcode contest. So good luck. Okay, it's loading. Probably at the end I will explain my solutions. Okay, what happened? It's loading super slow. Okay. Okay. So an S&T has to be of the same length as A. Okay, is different. Is length of this strings is different, then false. Hmm. Okay. Oh, okay. Mm. Hmm. Okay, everything was accepted. I guess I was quite slow, but let's see. Okay, I'm 9. Hopefully everything will pass. But I'm not sure if here we have a system testing or not. So I'm not sure about it. Not bad, but on problem C I was quite slow. Here I was also quite slow because I was confused a bit, but that's fine. Well, problems are, I guess, interesting, especially the last one. Okay, then let me try to explain all my solutions. So since I'm not prepared, I mean, I'm just doing this right away. I finished contest, so I'm sorry in advance if my explanations wouldn't be that clear. So I think my like you can hear me well. Okay, so let's start from the first problem. So in this problem, you just need to find a case missing number, positive number. So what I did here, I was just trying all possible answers and checking if this number exists, like occur in the array or not. If it doesn't, I just subtract k, and when k is equal to 0, which means that this is the case number which is missing. So I just return this number. Yeah, that's it. Yeah. Okay, let's go to problem B. Yeah, on here on ice. Okay, I guess it's better not to explain the problem statement because it will just take a lot of time to explain. Yeah, so if you don't the problem statements, just go and read it. So here for so first of all we need to check if the sizes, like if the length of these two strings is different. So if it's different, then the answer is false for sure. Okay, the case when they are equal. Okay, okay, so I have two strings for same length. For each position, like for each letter, I check how many times or what's the size of shift I need to have to make these letters equal. So yeah, I have two cases. I think it's just overcomplicated, but anyway. What I mean that you can make it simpler, but anyway, let me just explain my approach. So if first letter is smaller than the second, then for sure number of shifts or the size of shift has to be ti minus si. Okay. So if this number is greater than k, then for sure you can't make these letters equal. Otherwise, you want to use such shift. But sometimes it happens that such shift is already used. Well, if it's used, then you're trying to use the same shift but of size by 26, like bigger, because like alphabet is cyclic, and if you will make another 26 shifts by one, you'll get the same result. Yeah, thus I just like for each shift I check if that shift was used or not. If it wasn't, I say okay, now I need to shift like by that amount of units. Otherwise, if it exists, I take the last shift and yeah, I just like increase it by 26. Yeah, because I will get the same result. And afterwards, I just check if this number, if this step, yeah, right, doesn't exist k. If it exists, then I just return 0. Yeah, and the same actually for second case. Yeah. But again, I a bit overcomplicated, so you can make it much simpler and clearer. more clear. Okay, let's go to problem C. So problem C was a bit confusing because at the beginning I saw that a string is balanced if it's normal balanced, like parenthesis string, but actually it's not. It's a bit different. So for each such bracket parenthesis, you need to have two closing brackets parentheses. Okay, so what I did here, I was using a variable which here stands for number of open parentheses that are not paired with any bracket yet. So so I just go from left to right and I see check if that parenthesis is open, like opening. Yeah, let's say this parenthesis opening. So I just increase this counter by 1. So otherwise my current parenthesis is like closing, and I check if next parenthesis is also closing. Then this means that I need to so here if I have like two closing, this means that at the left I just close a certain opening parenthesis. So thus I decrease this counter by 1. But sometimes it might be that there is no such opening parenthesis or bracket, let's say. So in this case, if counter became less than 1, I just increase answer by 1. Yeah, because I just add this extra needed opening bracket. Well, and another case when next bracket is not closing, let's say it's opening, then I don't care, I just add new parentheses like that. So thus I also increase answer by 1. Okay, and at the end I have like that many open parentheses that are not paired with any parentheses yet. So thus I need to add that many closing parentheses to match that many open like brackets. And yeah, that's it actually. Okay, and now problem D, the last one. So which should be a bit hard to explain, I guess, but let's try. So yeah, so we can make any number of swaps in order to make a substring a palindrome, to make it palindrome. So let's suppose we have a substring. So it will be counted as a palindrome if all digits, if number of occurrences of all digits is even, right? So if it's even, we can make this substring palindrome. If all if number of occurrences of all digits is even, then for sure we can make this substring palindrome. But there is one more case, is when number of occurrences of all digits except 1 is even. Yeah, because you might have such palindrome. Let's say 1 and 0, 0. Yeah, that's still palindrome. So one digit has odd number of occurrences. Okay. Yeah, so this is actually very important note here, because like only using this observation, I guess, I came up with a solution. Well, what I did. So let's say if I had an array or string of digits. Yeah, so substring will be like, I consider a substring to be a palindrome, or I can say that, let's say substring is like awesome or good only if all digits occurs even number of times, or all digits except one occurs even number of times. So let's say that I will store a mask, like 10-bit mask, which will represent number of occurrences, not number, like parity, I guess, parity of occurrences. So let's say here I will have 1. So bit number, bit 0 will be 1 if digit 0 occurs odd times, like odd number of times. Yeah, sorry, if number of occurrences is odd of that digit. Yeah, so that subject will be a palindrome if mask has no more than 1 bit. Okay, I think that's clear. And for example, here we can use the same logic as with prefix sums. So for example, if we know mask, so for example, if we want to know mask for a certain, let's say, substring from left to right, like we want to know mask for all digits from left to right, these are like positions indexes, then we can just apply the same logic as with prefix sums. So that will be correct. Yeah, again, this is the same logic as if it was with prefix sums. For example, if a certain digit was out here and was out here, then then actually it is even in that substring. Yeah, so okay. So let's suppose that all digits occurs even number of times. So if it is so, then the result of this thing has to be equal to 0. So what I do here, like I just iterate from left to right, and for each mask I save the very first position of that mask. So if a such mask was already like occurred before, yeah, I mean if we already had such mask, then I can try to take this length as an answer, because substring from that position to position I will give like result will be 0. Like this thing will be 0. Yeah, but sometimes, as I mentioned, 1 bit or 1 digit can occur odd number of times. So to check that, I iterate through all such bits, and I suppose that bit j occurs odd number of times. And then I just try to find such mask. Then I'm trying to find such mask where on that range only that bit will occur odd number of times. Yeah, and I just take that distance, and that's actually it. I hope it was clear, but again, if it wasn't, you can just ask the questions below in the comments. So I think that you probably like this screencast plus like also my explanations. So press the button like button, subscribe to my channel, and see you in the next video. Bye bye.